Right now we're going to cover three different topics. We're going to cover destructive versus non-destructive methods. We're going to review object-oriented programming from start to finish, probably a little faster this time. And then we're going to go over something called regular expressions, or REGEX. So I'm going to jump back into my desktop real quick. How do I create a file without right-clicking and saying new file? Touch. I'm going to do examples for today, examples.rb. I'm going to subble examples.rb. I've got two windows open for right now. I just a place to evaluate my code and a place to write my code. So I want to cover destructive versus non-destructive methods, and it's important to note the difference as you are starting to write code, because sometimes you'll see things blow up and you're not going to understand why. So does anybody know what a destructive versus non-destructive method is?
Yes, the one mutates whatever you're working on. The other one doesn't.
Yep, that's pretty much it. So a destructive method is one that alters the original, completely changes the original thing that we had. And a non-destructive method is one that doesn't change anything. One that you know really well is basically let's see, array equals 1, 2, 3, 4, 5. One that you know really well is pop. So let's take a look at what we've got here. So I wrote the code. I'm just going to dump it inside of IRB here. So I have the array 1, 2, 3, 4, 5, and then I popped off the last thing and it returned me 5. Pop is an example of a destructive method, because when I look at the original array again, I only get 1, 2, 3, and 4. So this pop returns me something, but it also destructively changes the original. I can never get back the original from what it is. I could add 1 to it, but the moment I call pop on it, it's immediately changed forever. What's the one to get the first letter? Or, so the first element, sorry. It's just shift. And you can see that array shift returns me 1, but if I look at array again, I get 2, 3, 4. So I'm destructively changing the original. The original is no longer 1, 2, 3, 4, 5. First it became 1, 2, 3, 4. Then it became 2, 3, 4 when I jumped off the first one. And then this is my result of what I've got here. So I've got my pop, and I've got my array.shift, and then you can see that my array was going to be 2, 3, 4. So these are examples of destructive methods. When you're talking about Ruby, generally speaking, it's going to have a bang on it as well. Let's look at a non-destructive method really fast. So if I do array, each do number, I'm going to iterate over this array, which at this point is going to be 2, 3, 4. Each time through, 2 is going to be saved as number, then 3 is going to be saved as number, then 4 is going to be saved as number, and I just do number plus 1. So let me grab all of this, clear the screen. So I have my original array. I pop off one number. I shift off one number, and I have this array of 2, 3, 4. I'm going to iterate over each one of these numbers. This is a non-destructive method. I'm going to print out 2, 3, 4. Like the original does not actually change, even though I'm like doing something to it. I forgot to put a P here. Like you can kind of see that even though I'm printing out 3, 4, 5, I'm printing out that number plus 1. The original array does not change. Another version of each is map. So I'm going to do map, do number, same thing. P number plus 1. Jump back over and just print it. You can kind of see that array.map do number, I get that 3, 4, 5 again. My output is 3, 4, 5, but my original array is still 2, 3, 4. I'm not changing the original whatsoever. Non-destructive. When I add a bang onto it, though, and you can kind of see that most methods with a bang on it will basically say, like, I'm changing something. That's what you're looking for. So if you see a method with a bang on top of it, you're saying, I'm changing something. I'm going to do the same thing as I did before, but just add one small little bang symbol at the end of the method. Just dump it in here. Array.map. I'm still getting that 3, 4, 5, but when I do the array now, I get 3, 4, 5 rather than 2, 3, 4, which is what I had originally.
Is it like, oh, because you're created. I was wondering, like, is it both changing the original and creating new, but it's not changing?
Map bang is changing the original. Map returns you a new one, so I can actually set new array equals array.map, and then new array would be 3, 4, 5, but the original stays unchanged.
You just have to cache the variable of the non-bang one, right?
Correct, yeah. So that's a quick, dirty rundown on anything that is destructive. Generally, will change. Not generally, will change the original, and you're looking for bang symbols for Ruby. So if I open up one more window really fast, and I just do another Chrome window, I just do like Ruby string methods. You can look at this for hash methods. You can look at this for array methods. But if you just go over here and look on the left, you'll see that some of these some methods share certain qualities. So you can kind of see this has a bang on it. You can kind of see that when I do a equals hello and I capitalize with a bang, my output is going to be hello, but it changed the original, and a is now going to equal the capital H hello. Take a look. You can kind of see there's quite a few of these destructive methods. I have capitalize, delete, downcase, gsub, which we'll talk about later today, reverse, things of that nature. I'm altering the original, that bang symbol. Another thing that you can look out for is anything with a question mark at the end of a method generally says it's going to return true or false. Actually, 100% of the time, you should write your thing so that it returns true or false. So all of these things with like match question mark or start with or valid encoding, or I saw another one up here, case CMP, like all of these different methods are going to return you true or false. That's a little bit about destructive and non-destructive methods. Let's go over object orientation. On a scale from like 1 to 5, how comfortable are people with object orientation in Ruby? 3. That's a little bit higher than I was expecting. Anybody in like the 1 camp? All right, that's fine. Yeah.
In Ruby, yeah.
In Ruby, yeah. Okay. So let's talk. Let's just do an easy example. We used dog last time. Well, let's do a car this time. So we're going to create a class called car. And again, object-oriented programming is the way of organizing your code in such a way so that it's easily reusable. Instead of having just a bunch of methods that exist on their own, I'm going to nest them all within a class so I can use it over and over again. You can think of these objects as nouns, and every single noun has attributes to it. And every single noun has the ability to do something. So it also has the ability to do verbs. So we have a car, and tell me a little bit about a car. Like, so whenever car manufacturers create cars, there's certain attributes that they're able to give to it. So initialize.
Like make, model, year, color.
That sounds good to me. Make, model, year, color. So every single car, so let's say let's say everyone here has a car. So we have Ed's car, we have James' car, and we have John C. car. We have Jackie car. Let's say we have 4 different cars. Because I have this object or this class called car using object-oriented programming, I can reuse code over and over again. Like it's every single car that I create will have a make, model, year, and color, and they will all be able to do certain things. What are some things that all cars can do? Drive. I should go vroom, vroom. They can reverse.
They can break down.
Sound of tiny truck backing up. And then they can also break down. Yeah, we could do that. I'm just gonna keep this for now. Oops. Incident. So I have a car. It's a noun. It's a class that I know that I'm going to create many instances of. And when I say instance, we're thinking about like if we are all from class person, we are all individual instances of people. So when I create a new, like when there's a new human created, each human has a name and a skin color and et cetera, et cetera. Whenever I have this like master class called car, each individual instance of car has a different make, model, year, and color. So we'll do something real fun. I think it's fun. Ed, tell me about your first car that you drove. What make was it?
Cadillac.
Cadillac. Okay, we're starting off high. All right.
Chrome.
Okay. What color? What year?
85.
1985. And then the color?
Silver.
Silver. All right. James, tell me about your first car that you drove.
It was like a 1990 Toyota Camry.
Toyota Camry, 1990. What color was it?
White.
White. John, tell me about your first car.
Another Cadillac.
Jeez. All right.
Chrome.
How do you spell?
BROGHAM. Elegance. Or just Chrome.
Okay.
92. It was triple blue.
All right. Jackie, tell me about your first car.
I had a Jeep,
Okay.
a Wrangler,
Mm-hmm.
1992, and white.
White. Great. All right. So we have 4 cars here. Each one of these cars is an individual instance of a car. Now, each one of these cars can all do similar things. They can all drive, they can all reverse, they can all break down. And let's say you can also decide that you want to sell it. So, or you want to tell people about your car. You want to tell people about your car. Okay, so tell people about your car. When I tell people about my car, when I say like, let's say, Sean, what was your first car? Like you have let's say the car has the ability to tell you about itself. Wait, this is not. Tell people about yourself. Let's take your headspace away from being a human for a bit, and let's pretend that you're an actual car. And if the car had the ability to tell people about itself, what would you say? Like,
I'm happy to do what you tell me to.
no, I meant like what? Like if I tell you like so so it's like I walk up to Tristan and I say, tell me about yourself, right? There's different attributes that it's like, I'm Tristan, I'm X. Yeah, okay. All right, I am so I'm thinking like I'm a 1990 silver Toyota Camry.
Sure.
So let's pretend like a car can talk to you for a second. I am a year, make, model. I think the color comes first, right? Color. So every single car can do these things. They can drive, reverse, and break down. Those are things that every single car can do, and they all are going to look fairly similar. Every car, when it drives, it goes forward. Every car, when it reverses, it goes backwards. Every car, when it breaks down, no longer runs. But there are things that each individual car can do that's shared, but it will give you a different result. Like when I walk around the room and I ask you, what is your name? That's a question that every human being most human beings can answer, but all the responses are going to be different based on the attributes that you were given. So similarly, we've got this car here. They can do all of these things, but when I say, tell me about yourself, it's going to tell me things about itself, but based on the attributes that each individual car has. So there's this concept inside of object-oriented programming called basically instance variables, getters and setters. So we have basically, let's say output equals broom broom, and then it's going to just give me output. Output is a local variable, only exists within lines 5 and 8. Only exists here. I can actually do another output over here, and basically I can have output in every single line of code that I want. Obviously, these are poorly named variables, but because they're local variables, I can overwrite them very quickly, and it only exists within this particular context of def and end. This is why indentation is fairly important. You can kind of see output is nested within this def and this end. This output is nested between this def and this end, and so on and so forth. So that's a local variable. It's 99% of the variables that you're going to use. There's also ones called instance variables. Instance variables are variables that are available to every single instance of this particular car. So I could do @make equals make, @model equals model, @year equals year, and @color equals color. I'm saying I'm creating an instance variable called make, which is going to read this particular whatever I pass in and save it as that. So for Ed's car, he passes Cadillac as the first argument. It's saved as make as a parameter, and I'm setting the instance variable of make to this particular car. And then the same thing with the model, year, and the color. Now, because I've defined it as an instance variable with the @ sign in the beginning, I can use it in any of these things that I want. So I can just do room plus @make. So this would say vroom Cadillac, and then vroom Toyota, vroom Cadillac, and vroom Jeep. Let's just see if that works. I'm going to do this real quick. Ed's car dot drive. So I've got 4 cars, and I'm just going to make them drive. It's going to say vroom, and then the make of the car. Let's just see if this works. It would help if I had print statements in front of all of these. So vroom Cadillac, vroom Toyota, vroom Cadillac, and vroom Jeep. In that order, because that's the order that we called it. So as long as I have this @ symbol in the front, it makes it an instance variable. I can use it in any method, but I cannot use this output in any other method, because this is a local variable. Now, I can do a few things for the tell me about yourself. Let me just get rid of this .drive for everybody. Just do .tell people about yourself. Yes?
Those instance variables, they have their placement is always right underneath your initial function?
Not necessarily, but 99% of the time, yes. I could easily just do, once you drive, let's say a car has a certain number of miles, right? I can just say, the moment you start driving it, I can just do @number of miles equals, like, let's say, equals 1. The moment you drive it off the lot, I'm going to set the number of miles that you drove to 1. So at this particular point, this instance variable is created only when I call drive.
Right.
But 99% of the time, it's going to be just up here.
I understand.
So I can do a few things. One, I could just do @color, @year, @make, and @model. And this is a totally fine way of going about it for right now, if this is the way that you understand it. Like just saying instance variables are variables that you can use within the entire instance of one class. So let's see this work. I'm a silver 1985 Cadillac Fleetwood and all the other different things that it says. That being said, these instance variables sometimes can be either read or written to. So I don't like to, most of the time people don't like to see all these @ symbols everywhere. So I want to make these all into methods. So I'm going to do def color. That's going to return me @color. Def year, which is going to give me @year. Def make gives me @make. And def model gives me @model. Let's see that if this still works. I still get the exact same output that I saw above. So basically what happens is I create my new car and I tell the car to tell me about itself. It goes to, I am a color. Color is not defined within lines 40 through 42. So it looks inside the entire class. Is there a method called color? There is, and all it does is return an instance variable. As you can kind of see, this is pretty verbose. It's, you know, an extra 12 lines of code. And for every single thing that you initialize it with, you're probably going to need to create another one of these. So instead of doing that, I'm going to do this concept called a attribute reader. Make, model, year, and color. What this is doing is it's saying, once I define the instance variable, I'm going to make all of those instance variables getters. So whenever I ask for the make, it basically says, whenever I make an attribute reader, it's the equivalent of these 3 lines of code. Whenever I ask for the year, it's the equivalent of these 3 lines of code right over here. So I can get rid of all of this. So now when I tell the car to tell me about itself, it's looking for the color, and there's no method here, but because I have a reader up top, I'm able to read the instance variable very quickly. Same thing as before. There's also a concept of writers. So as the car ages and as you get cars, there are a few things on this car that can change. The make can never change, the model can never change, the year can never change, but I believe that you can change the color of your car pretty easily. You know, it's $800 or something like that to get a nice, a new coat of paint. So when I want to overwrite the color, let's say Ed's car, he's got this 1985 Cadillac Fleetwood. Do you still have this car, Ed?
No,
What's that?
somebody hit me.
Somebody hit you. Okay, okay. Did anybody sell their car or give it to somebody else? All right, John, you had this triple blue, but you sold it. You sold it to somebody else. When you sold it to somebody else, let's pretend that they no longer like this triple blue. They want to go with Marlboro Red or something like that. At this particular point, let me comment this out. John's car is a, when I tell John's car to tell me about itself, it says, I'm a triple blue 1992 Cadillac. But the new owner doesn't like that anymore. So John's car is now going to change its color to Marlboro, I don't know,
Yep.
Red. Is that correct?
B-O-R-O.
Okay. And then when I tell John's car to tell me about itself again, hopefully it will tell me that it is red. So I run this code, it breaks, and it says there's an undefined method color equals. So when I want to overwrite something that's already been initialized, again, like if you get married and you change your last name, or like if your parents got divorced when you were a kid and you had to take one person's last name and change your name and stuff like that, you were given a name and then it was changed to something else. Same thing here. I have a car, it was triple blue to begin with, and then I decided to recolor it. So I can do this. I can just do def color equals, and then new color, and then at color equals new color. This is one way of doing it. So I'm going to change, again, I have John's car. I'm going to tell people about it. I'm going to change the color after John sells it, and then it's going to say something else now. So it says, I am a triple blue. Now it says I'm a Marlboro Red, 1992. So certain attributes can be red only, and certain attributes can be read and written. So for us, we are changing the color from one thing to another. Obviously, these 3 lines of code are kind of, if you can kind of figure out, there's probably a shorthand way of doing it. If an attribute is something that you can write over, then you can just shorten this all down by doing an adder writer. Yes?
So, this is like I'm trying to do an equivalent. So like in JavaScript, I get how this all works, but sometimes you don't want to write the at, various places in your code, so you just cache it in a different worded variable, refer to it that way. Do you do that inside of Ruby?
No. Yeah, you define the add symbol once. You generally make it into an adder, reader, or writer, and then you can just use it just as a method. Yeah. So I got rid of these 3 lines of code, this color equals, and now I have the exact same output. Finally, when you see something is both a reader and a writer, you can combine that into what's called an adder accessor. You can access it both as a get and a set. Accessor and color, and then you can get rid of this. And it still runs.
Is there ever instances where something should just be a writer?
Are there ever instances where something should be just written to?
And some weird encapsulation a little bit?
I think there's probably an example that I can think of. I just don't have it off the top of my head. I'm thinking of some sort of like banking software.
Yeah. You don't want people to know what's actually being messed with inside.
Something like that. Yeah, I don't have a perfect example off the top of my head. How are people feeling about object orientation? Feeling okay? A little bit better? Okay. It just takes a little bit of time, and then we haven't been doing a terribly large amount of it. For the thing on Friday, it's basically just, can you do an initialize? Can you write methods? And can you pass in variables from what? Can you pass in instance variables from your initialize into other places?
I think I'm just wondering, what are the benefits of using the object-oriented programming versus like just, I guess, regular programming?
Yeah. What's the point? What's the purpose of like throwing all of this inside of a class rather than just writing a bunch of methods? It's the whole difference between. It's a very long conversation, but it's essentially the difference between what's called functional programming and object-oriented programming. Functional programming is faster because your computer doesn't need to memorize, oh, I created a car with these 4 things, and then I have to keep track of that forever. That being said, it's mostly used for code organization. Yeah, that's pretty much it. When you start organizing your code and thinking about it in like real life situations, it's just easier to organize this way. Everything that's related to car will be nested within this car class.
Could you ever just use like a combination of the two, like functional and?
I'm sure you definitely can. Yeah. I'm going to get to Ed and then Sean and then Tristan. I mean, not Ed, James. Sorry, I saw Ed.
Since this is going to be on our assessment, is there a place where I can practice this, like some sort of tutorial?
Create a bunch of classes. Like short answer, no.
Yeah. There's a couple of really. I started studying this a couple days ago. There's a couple of really videos.
Sean.
As far as these assessments go, I'm just curious, like, is this like a thing where you can't use the internet?
No, it's open everything. Yeah. Tristan.
We're doing it for the assessments are for both languages, right?
No, the assessment it'll be very clear which language I want you to use.
Okay.
On Friday, it's just Ruby.
Okay.
Yeah, because it's object oriented. And I didn't teach JavaScript object orientation.
That's why I was asking.
Yeah. Yeah. Friday's assessment again. It's going to be an algorithm mixed in with a class, and then it's going to be in Ruby.
Both of those.
So it's actually one algorithm that's using object orientation.
Oh, okay.
Yeah. So it's just one. It's just one problem.
No recursion.
No recursion unless you want to use recursion. Anything you can do recursively, you can do iteratively 99% of the time. All right, last thing I want to cover for today, and we'll get started on the work, is this concept called regular expressions. So let's go to a site. Let's go to my old employer, onemainfinancial.com. All right, so I'm very familiar with this site. So let's, I don't know, $2,000. Get started. It's going to take me all the way over here. So this is a form. The entire web is one giant form. Like in case you haven't realized, just do anything on the internet, it's a giant form. If you want to look for a product, it's a form. You want to give your credit card information, it's a form. You want to send an instant message to somebody, it's still a form. You just have to type in what you want to type in. So everything is a giant form. And on these forms, you always have to rely on different things happening. So let's say I'm on a website and I'm going to just apply for this particular loan. When I'm inside of an email address and I just do whatever and I move on to the next thing, it says, please enter a valid email address. How does it know that I didn't type in a valid email address?
Looking for the character.
Yeah, it's looking for an @ character and a dot character. So if the text that you enter does not follow that particular pattern, I don't want to take your data. It's bad data, right? And you can just kind of imagine the sheer volume of crap that people have to like. So on average, like we were like a small to mid-sized company, probably about 1,000 to 2,000 employees or something like that. We probably had, 50 to 100,000 people visit per hour. And if you have 50 to 100,000 people visit per hour, and they're filling out garbage every single time, like your database is just going to have 50 to 100,000 records of garbage potentially. So you want to make sure that you are protecting yourself at all costs. You have to basically assume as web developers that every single person on earth is trying to hack your site at any given time. This almost never happens, but you always have to protect yourself as if that is something that's going to happen. It's either someone is actually trying to hack your site or someone broke your site by accident. Like, it's just like, I didn't know what I was doing. I clicked around I filled out something wrong and then everything broke. So you always have to protect yourself as much as possible. The easiest way to do that is just using form validation. Underneath form validation, they're using a technology called regular expressions. And regular expressions are basically just patterns that you use to match character combinations. Here inside of this email address, I'm looking for the @ symbol and a dot. Like if you don't have those two things, you don't have an email address. Similarly, if I go to a phone number down here and I type in letters, it's not even letting me type in letters because phone numbers don't have letters inside of them. All phone numbers have have only numbers. If I try to do a bunch of periods and things like that, or any special characters like a bang symbol, it's not going to allow me to do that. Similarly, I can't type in more than 10 characters. It's going to stop me over here. These are all like examples of like front-end validations that happen on the browser. But there are technologies powering it, and that's that regular expressions that we're talking about today. So basically, it works like this: a user inputs some sort of text. You will write regular expressions in whatever language you decide. It's going to read that input and pattern match it. If you're looking for a social security number and you add in a bunch of letters, that's not a social security number. If you're adding in 27 numbers for a social security number, that's also not a social security number. A social security number has 9 numbers, if I'm not mistaken. So you're looking. Let's see. Okay, you can let me know what your social security is, so we can count, right? So this is really really important for things like phone number inputs, social security, email. Like, you want to make sure that, and for things like this morning we were saying, when we were iterating over the character for Caesar cipher, we wanted to see that everything that we were entering, if something was a letter or if it was not a letter, we're going to be using regular expressions for that. There's not a really terribly good way of saying how to teach regular expressions, but I'll do my best as quickly as I can. So regular expressions is in every single programming language. The syntax of how to use regular expressions is is slightly different between every single language. So let's say I have my social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a string, and I want to just use some pattern recognition to just get out the numbers. So again, this string has both letters, spaces, and numbers, and I just want to get the numbers out. The good part about today is it's kind of like a reset for everybody. Like, nobody is going to be supremely better than anybody else or worse than anybody else when it comes to regular expressions, because regular expressions, you don't really need any prior knowledge. It's basically just using how well can you reference all of the stuff down here to create a regular expression to get something out of a string. So it's a nice reset for everybody. So looking down here, I want to look for, I have a string, and I want to look for 3 digits, dash 2 digits, dash 4 digits. And I need to I need to create a regular expression using all of this stuff that I have in here in order to capture that. So I'm just going to kind of look through it. Any character of A, B, or C. Does anyone actually know off the top of their head how to do this? /D, / or backslash? Back. It's actually back. So you can think, so / and backslash is kind of stupid. Imagine a person standing straight up. If you're leaning backwards, like this person, it's a backslash. If you're leaning forward, it's a /. So it looks like there's a \D for any digit. Cool. Boom. You can kind of see I did \D. It's within these 2 /, and it gets me all the numbers. That's great. What happens if I do this? Now your social security number has 27 things in it. I'm looking for a specific pattern of 3 digits, 2 digits, 4 digits. So when I just do \D, I get all the digits.
It's like early places, 3.
Yeah, let's take a look.
Something like better.
So I have any digit, and it looks like when I pass this A3, it says exactly 3 of A. Okay, so maybe if I do \A, if I do \D with the 3, maybe I'll get something.
So then you could just do put that inside of the brackets, I guess. So that it would be limited to once, and then you would do it another time with like the next.
Yeah. So you can kind of see it's just kind of like pattern recognition. The actual answer is \D3, \D2, and then \D4. So you can kind of see, even though I had a bunch of other numbers here, even though I had a whole bunch of other numbers, they didn't follow this particular pattern, which was any 3 digits followed by a dash, any 2 digits followed by a dash, any 4 digits. And then there's things like phone numbers. Phone numbers are the worst thing in the world as a web developer. You have to worry about people doing dashes. You have to worry about people doing dots, people doing those like the parentheses and then the space and then the dash, which is like what I do. But there's so many ways to input phone numbers. And what you need to worry about is like, I just want to get the numbers. I don't care about how you're formatted. I just want to get the numbers. So let's say if I have like 1, 2, 3, 4, 5, 6, 7, 7, 8, 8. That's a phone number. 1, 2, 3 dot 4, 5, 6 dot 7, 7, 7, 8, 8. What's that?
I was just thinking you just want to make sure it's kind of digits.
Yeah. 7, 7, 8, 8. So these are 3 different ways that people decide to just put a bunch of stuff together. I should think there's one more. It's just a bunch of dashes. 1, 2, 3 dash 4, 5, 6 dash 7, 7, 8, 8. These are 4 different ways of just writing phone numbers. I want to create a regular expression to just care about these phone numbers. Like I don't care about if you put any dashes in there, parentheses. What do you think we should do? There's no real skill to this. It's just bang your head against the wall till something works. And then you start to memorize what works for you.
Definitely the bracket, the curly bracket 3. I think we would definitely want that.
So just like this? Oh, I need the \D for the any digit.
Yeah. And then
Another one?
yeah, another one.
What's the objective?
You just want the phone number, can you just put 10 in there?
So to going back to Tristan's question is, what is going, like I have 4 ways of writing phone numbers and I just want the numbers themselves.
Yeah, it's \D, curly bracket.
You're just looking for the digits.
Yeah.
So you can enter it however you want. You can enter it like this. You can put dots in it. You can put dashes. You can put spaces. You can put new lines. In the end, I'm just looking for 10 characters. I think it's 10, right? Yep. But then I forgot about all these.
Is it 1 ... n?
Ignore. There's an ignore
If
function.
you can ignore
Where's the
anything
ignore?
else that's not a D,
Any non-digit is
You put that in.
/0, right? Or /L, or /big D. whatever that
Slash
is.
big D.
And then you just put the ignore key in front of that, which is I think a caret.
Lowercase I.
A caret. A caret goes front of line, I think.
Okay.
Start of line.
they actually have to put it inside.
So if we just do \D3 \D3 \D4, that would give us
Well, it's still. I need to get rid of all of these here.
but okay.
So we're still at that same thing where it's like it's 3 digits. What you're saying here is I'm looking for 3 digits followed by 3 digits followed by 4 digits. 3 digits, but it's not followed by 3 digits because I have this extra dot right here. We tried 10, but that's saying I'm looking for any 10 numbers in a row.
Is it \lowercase d curly brackets 1, 10 or 1, 9?
Like this?
Yeah.
Nope, I still get the first one. I'm not getting all of them. Sean?
You could ignore all characters that aren't
Whoa.
digit.
Whoa. I just got something. I didn't do anything. I just decided to work all of a sudden. 1 and 9 does work.
Mine's
But I could also add another one here, and that also works.
Yes. I knew it was gonna happen.
Well, I'm also just adding numbers here, and it's still working. So, like, I'm not sure what the answer is, to be honest. You could Google this very quickly, but you can kind of see, like, regular expressions, very, very useful, especially in like front-end form validations, and definitely for your algorithms. I think it's looking for, let's see, between 3 and 9 of A. So it's looking between 1 and 9 of any digit. And because all of these are like, at any given point, I can start and count up to 9, I think all of this is going to work. We can just look it up real quick. Regex for phone number. It's actually really easy.
Wasn't that a solution as well?
This was a solution, but I can actually add any number of things, and this is no longer a valid phone number, and you need to work 100% of the time. Yeah, Sean?
Before we end today, can I ask you to show me like one thing?
Sure.
Like before, when it's not regex, just another thing I asked you. It's something I just want to see how you handle it.
Okay, that's fine. So let's take a look at what we've got for today. Today is Wednesday, which means that it is pairing day. I believe there's an odd number of people here. So figure out somebody that you want to work with. It's week 2, Wednesday. We have a few challenges, not a terribly large amount. The first one is just a tutorial. There is no real good way to teach regular expressions. It is really just, here's the concept, here's a few things, a few sites, and here's a few things that we can go through, and then you just need to go do it. There's a great online resource called REGEX 1 that, it's kind of fun. It's kind of fun just to kind of like bash your head against the wall until this works, and then once it works, it's very rewarding. We have phone numbers and Ruby regular expressions, then 2 algorithms for today, stock picker and sum pairs. So most of your day, I think, will be spent doing these first 2 things until you understand regular expressions a little bit better. And then probably these things will come a little later in the afternoon. Tristan?
Going through, I had to do a regex for, I can't remember what it was, but there was a method called :ord. Is that?
I don't know what that is.
Oh, okay.
It's when you're converting from a letter to a number.
The Unicode?
Oh, okay.
Oh, okay. Yeah, I think those are, I don't think that's related to regular expressions.
So can you do a for loop within a for loop inside
Oh, yeah,
Ruby?
sure. I had one request to do a loop within a loop. Let's go back to here. Let's open up examples.rb.
The specific thing that is strange to me is that in JavaScript I can decide specifically how long I'm going to loop because you have like the 3 factors instead of 4 loops.
Yeah.
And so I can decide kind of in the loops how to validate what they're looking for within those contexts, but I don't know if you can do that inside Ruby, so it's harder to use a loop there.
Sure. So loop within the loop, I'll start by saying you should probably not do loops within loops because it's basically like if I have two arrays and I'm going to loop over each one, like person A goes with number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's has very bad performance. It's O(n) squared. But let's say we have a loop within a loop. How do we do that? So let's say we have
What was the word you used? You said it has very bad what?
performance.
Oh,
Yeah. We'll talk about big O notation, which is the performance of algorithms. But it is one of the worst performance issues when you have a loop within a loop because you have to do that. If you have an array of 10 things and an array of another 10 things, you have to do the loop 100 times. That's the way that squared comes from. So if I have array 1, 1, 2, 3, 4, 5, and then array 2 of 6, 7, 8, 9, 10. And I wanted to like print out like 1 and 6, 1 and 7, 1 and 8, 1 and 9. I'm just going to do array 1 dot each do number. And then within here, I do array 2 dot each do number 2. I'm going to do print number 1, number 2. This is a nested each loop. So the first time through, I'm going to do array 1 each do number. So number is equal to 1 the first time. Then when I'm going to iterate through array number 2, the first time through is going to be 6, and then the second time is going to be 7, 8, 9, 10, but that's all within this first loop of number 1. So if I print this, if I just call loop within a loop, I just call this inside of examples, so Ruby examples.rb, 1 to 6, 1 to 7, 1 to 8, 1 to 9, 1 to 10, 2 to 6, 2 to 7, 2 to 8, 2 to 9, 2 to 10. So a loop within a loop.
That's it.
Yep, that's all.